DML Part 3 of 4. Thus far in this journey through data manipulation language statements in SQL, we've learned about the select and insert commands. Next up is the update command, which is what we use to change or modify values in one or more rows in one or more data tables. So we'll learn all about update, and in so doing in the demo, we'll also give you a refresher recap on using select and insert, just to make sure we're fully comfortable with all of the DML statements we've learned thus far. Specifically with regard to the update statement, I'll show you some provisions we can take in MySQL to prevent dangerous updates that affect more data than you actually intended to modify. We'll also look at how to perform multi-table updates, for instance, taking data from one table and shipping it to another one. Let's get to work. So, what is the update statement? Well, the update statement is a standard ANSI ISO SQL DML statement that's used, as I already mentioned, to modify the content of existing records. The basic syntax for update is pretty similar. In fact, it looks like one of the two syntaxes we learned for insert in the previous nugget. Let's take a look at code sample 1. If we wanted to update the personnel table and change one row of data, what we would do is specify update target table name, use the set command, and then a comma-separated list of any columns that we want to change. In this case, it looks like we're changing department ID to 20. Now, that's what you want to change. The where clause is where you specify the condition. In other words, we want to update the personnel table and set the department ID column to 20 where employee ID, or emp ID, equals 10004. All right? So for whoever this employee is, we're reassigning his or her department from whatever it was previously to 20. Now, if you want to change the values of more than one column, as I just said, you would separate those statements with commas. Simple as that. So in code sample 2, we're saying update the personnel table, set department ID equal to 30, comma, last name equals to Smithling, again, where emp ID equals 152. Now, the theme here is that the where clause is absolutely crucial in your use of the update statement, and this is to prevent unintentional data modifications. You'll remember with MySQL, when you issue a statement like insert or update, provided your syntax is correct, it's gonna happen. There's no undo in MySQL. Especially important with the update command is to use this where clause. Otherwise, if we didn't use the where clause, your update would affect every row in the table. If we just said update personnel, set department ID equals to 30, last name equals Smithling, and forgot the where clause, then every single row in that table would have a department ID of 30 and a last name of Smithling. So I can't drum that into your head intensely enough to keep in mind that where clause. And I'll show you a provision in MySQL where we can configure the server that would actually not let you do an update or a delete statement without where. As we're going to see in the next nugget where we finish out DML by examining delete, delete has the same dependency on the where clause. The question is, how do we prevent dangerous updates from producing unintentional data modifications in our MySQL tables? There's a couple ways to go here, friends. One is judicious use of the limit statement. We learned about limit in a previous nugget when we did select. Limit's pretty cool because it can, well, limit the number of rows that come back from a particular DML statement. Now, limit works with updates and deletes both in a really neat way. For instance, let's look at this code sample. If we're updating personnel and setting the last name equal to Bradley, where the last name equals Lipschitz, well, that would be wonderful if there were just one employee in this personnel table with the last name of Lipschitz. Admittedly, this is not the most common last name. Smith probably would have been better for me to use. But let's just imagine that there's a couple Lipschitzes in our personnel table, and we only want to modify one of them. Well, remember, if we just issue this update, even with this where statement, without any other provision, we're going to change both Lipschitz employees to the last name of Bradley, and that may not be what we want. Therefore, limit can be used with updates in order to apply the update only to the limit number that you provide. In other words, if we issue limit 1 with this update statement, then MySQL will run the table scan, and the first Lipschitz it finds, it will change to Bradley, then it will complete the transaction. Now, of course, the question comes in, how do you know you're getting the right Lipschitz? Well, what you'd want to do there is add the order by statement, and you can order by, well, you could do employee ID, you could just choose another column and do an ascending or descending sort to ensure that the Lipschitz you want to change in this case is going to be the one you want to change. You see what I mean? Or if we had last name of Smith that we were changing, and there was a Carl Smith and a Sam Smith, we could do an order by first name ascending, limit 1, and that way we would make sure to change Carl Smith's record and not Sam. So therefore, the take-home message is limit is an awfully flexible tool that we can use with the select statement to cut down on the rows we're bringing back, as well as in the update statement to ensure that we're only modifying a certain record. Now, a more permanent option is the SQL Safe Updates option. Now, you can set the Safe Updates flag. It's binary, 0 or 1. 0 is off, 1 is on, and Safe Updates are off by default. You can set this in your MySQL option file such that each time the server starts, Safe Updates are automatically enabled globally. Or as you've come to expect, you can change server variables at runtime by using the set statement. So we would simply say set SQL Safe Updates equals 1, and then for the duration of your session, you would have Safe Updates on. Now, what does that do, actually? Well, the Safe Updates command, chiefly for our purposes in this nugget, enforces a where clause with both update and delete statements. So you wouldn't run into that problem, for instance, where you said update personnel, set last name equals to Bradley, semicolon, go, and then every last name in the table gets changed to Bradley. MySQL would bark at you if you had Safe Updates turned on and insist that you filter your update with a where. Other things that it does is that the SQL Safe Updates will limit the number of joins that you can have among tables and also reduce your select limit to 1,000 rows. So if you were to inadvertently run a select star against a table that had 1,000,000 rows, as long as Safe Updates were turned on, you would only see 1,000 rows no matter how many times you ran that select splat. Performing MultiTable Updates. This is a neat feature of MySQL, and things you can do in this context are things like updating one table by using the contents of another table. You can also update rows in one table, determining which rows to update by referring to another table, or you can update rows in multiple tables with a single update statement. So therefore, we see that this update is pretty darn powerful and allows you to extend the command across tables or among tables. Now, what the prerequisite skill is on your part is that you have to understand join syntax in order for this to work. And formally, if you're following these nuggets in sequential order, we haven't yet discussed joins. We will, but I've kind of given you some sneaky lessons here and there, and I'll give you another one now because really table joins are key to your understanding how relational database systems work. In a nutshell, to review, you'll remember that a join is a connection or a relationship between two tables. For instance, you've got the traditional example of customers and orders. And let's say in the customers table, we have a key field called customer ID. That's a primary key. If we want to relate customers to orders, and there's many reasons why we'd want to do that, we would separate customers from orders into separate tables because we're thinking of third normal form and eliminating data duplication. And we're also thinking of relating these tables, well, so we could do a foreign key relationship with referential integrity, such that if someone were adding rows to the order table, they would never be able to refer to a customer who doesn't exist over here. A third and wonderful reason is that when we create queries, we can use this join syntax to pull rows from both columns. So if instead of just querying the orders table where we're getting customer ID numbers, we can pull the customer first name and last name from the customers table and order information from the orders table by virtue of that connection. Now, how do you relate tables? As I've already told you, you create a duplicate column. In other words, this customer ID column over in customers, we would create another column in orders. We could call it customer ID, we could call it whatever we wanted, but we would use the same data type as what's over here on customers. And then depending upon our storage engine, if we were using a storage engine that supported foreign keys like InnoDB, we could add the foreign key constraint to really tie those two tables together. Therefore, in order to do a multi-table update, you have to have this matching column, this key column that's capable of joining the two tables together. Assuming you have that, you can then perform these multi-table updates. And here's how it works. In this sample code, we're updating two tables, products and orders, similar to my customers and orders example. And we're saying set prods.pname to orders.pname. Equal here is used as what's called an assignment operator. It's a programming term. So we're not saying that they're equal as such. We're assigning values. And you notice also we're using qualified syntax, where we're taking the table name dot the column name. Therefore, there's got to be a column that has the same name and data type in each one of these tables. Therefore, in this case, we're saying set the pname column in our products table, let me change this to P for products, equal to the pname column in orders. So whatever is in the orders column over here on orders, we're going to copy that over into the matching column over on products. This is a multi-table update where, and this is where the join syntax comes in, the product ID column over here matches the orders ID column, which is the related table, the related column with the same data type. This provides the row level matching that formally defines what's called an inner join. All right, I hope that explanation worked. The take-home message here is that this statement will copy the pname column data from the orders table to the prods table. That's the deal. Now it's time for us to convert theory into practice. We're going to fire up MySQL Nugget, log into MySQL, and practice this stuff. We're going to use the update statement, and we're also going to play around with preventing dangerous updates to make sure you're familiar with those techniques. In this demonstration, we're going to work with the update command in MySQL 5. Now, to walk you through what I've done thus far, as you see, I've logged into MySQL as the root user. I've done a show databases, and as you can see, I've created a test database called testDB. I've then used that database and run show tables. You can see I created a table that has the same schema as the table used in the previous nugget. Of course, we can say show create table emp to actually show you those column definitions. Basically, we just have an ID, that's our primary key, first name varchar, last name varchar. Now, both of those are not null. We're going to take up a subject that we started in the previous demo, the previous nuggets demo, on nullability and rogue inserts. And then finally, we have a salary column that uses decimal with a default value of 50,000. We're now going to insert 3 rows here, so let me fire up that syntax. Okay, I've inserted actually 3 rows. You're just seeing the last 2 rows I've put in here. I've inserted a row matching all 4 columns, ID, first name, last name, salary. I have Susan Harder with the default salary and the default ID. And then in this final statement, you'll notice that I'm providing default, Jeff, default, default. Now, the second default here maps to last name, and you'll recall in this table definition I specified not null. So it might be surprising when we run a select star from emp that Jeff has a blank last name. After all, didn't we specify, and I can show you again, that last name is a not null value. And I mentioned in the last nugget parenthetically that this dealt with the SQL mode. Now you can set your SQL mode on the server level, you'll recall, in your MySQL option file, my.ini in Windows, my.cnf in Linux. And in the server section of the file, you have an entry here called SQL-mode equals, and this is where you can provide one of those modes like strict all tables. You notice that my mode is set to null. Therefore, my server is running as permissively as possible. All we have to do to change this is say set SQL_mode equals to strict_all tables. And we can verify this by selecting against the global variable @ session.sql_mode. Need to type that correctly though. I threw in an extra S. There we go. And I can also, just for grins, run select global.sql_mode to look at the server level mode. And of course, as we've already seen, that is not working. All right, so why don't we just try this just to verify it, clean up some shavings from the last nugget before we start this stuff. We're going to insert into emp again, and we'll specify all those values. And we're going to say default ID, let's say Kevin first name, default last name, default salary. And here we see an error. Fast field last name doesn't have a default value assigned for it. It has the not null. So it looks like it worked. So let's just finish this off by saying default ID, Kevin first name, Van Hooser last name, default salary. So if we select star from emp now, we're good to go. All right, so this brings us to this nugget's order of business, and that is how do we make updates, not inserts, which we just reviewed, but updates to existing data. For instance, we see now that ID 3 in our emp table has a first name but no last name. This is a perfect occasion for us to make a change. You'll recall that in order to make an update, we specify update, table name, then we say set, and then it's just a question of you knowing your data and knowing your table and knowing your column names. In this case, why don't we set last_name equals to, since this is a string data type, we're going to use single ticks or single quotes in order to delimit the value. We'll set the last name to Singer, and remember the importance of where, let's use the ID to be really strict, where ID equals 3. That should be pretty easy. All right, so let's select from the table again, and we now have Jeff's last name changed. Now let's try an update that affects more than one column. Let's say that Susan Harder becomes married and she becomes Susan Warner. And let's say that a side benefit of that marriage is that her salary goes up to $75,000 per pay period or per year. Nepotism has its advantages, I guess. So to do that, we can simply say update emp, and then we'll say set last name equals to Warner, comma, salary equals to $75,000. So far, so good. And remember the importance of the where statement, where ID equals 2. Simple as that. So we'll rerun our select statement, and we now see Susan has a new last name and a new salary. That's literally all there is to it in terms of the basic use of the update statement. Now, what if we want to change Susan's salary again, but this time you'll notice the command will be a little bit dangerous. For instance, if we say update emp set salary equals to 100,000, Susan's moving up in the world, where last name equals Warner, well, this is going to have a little bit of an issue, isn't it? Because, as you see, we have 2 records in this small table with a last name of Warner. How can we ensure that we change Susan Warner's salary from $75,000 to $100,000 and not Tim Warner's salary? Well, this is a good case for using the limit command. First of all, we're going to say limit 1 to ensure that only one row gets changed. And finally, this is another case where order by is crucial. And what we can do to make sure Susan shows up first in this order is to simply say order by ID descending. You see how that works? So we're going to set the salary column to 100,000 for the last name Warner, we're going to limit the update to one occurrence, and we'll make sure that Susan's is the first row that's hit by specifying order by ID descending. And as you see, I had a syntax error, and this brings out an important point that sometimes your SQL command order is crucial. Just like I showed you a couple nuggets ago, when we use select, the order is select where order by. When we use limit, limit needs to be placed at the very end of the statement, such that my first run at this bailed out with a SQL syntax error. The second run was successful. And to review the second run, what I did is simply transposed my order by statement with my limit statement. So we're saying update, where, order by, limit 1. And we can verify that everything's hunky-dory by running another select against the table, and we see sure enough that Susan Warner's salary has been boosted to $100,000 and Tim Warner's has not. Now, as far as preventing dangerous updates are concerned, limit is one really nice way to do it. I also told you about the safe updates command that we can add as a set statement in the session, or we can add the statement to our configuration option file if we want to as well. Right now, MySQL is running in its default state, which is safe updates off. And of course, that can be dangerous because we can do stuff like this. See, if we update emp set salary equals to 25,000 with no where, with safe updates off, the query went through, 4 rows were affected. So if we select now, we see that the salary for all 4 records in this emp table have been changed. Not cool. Now let's try this again. First of all, setting the variable at the session level, SQL safe updates. We'll set this equal to 1. Now if we try the same update, we get an error. It tells us that you are using safe update mode and you tried to update a table without a where clause that uses a key column. You see? So that safe updates can be awfully helpful in terms of preventing rogue or dangerous updates to your data. The final thing that we're going to do in this demo is do a multi-table insert, where we're going to create a new table that has the exact same schema as emp, and then we're going to update or copy all of the data from the emp table and put it into our emp new copied table. In so doing, I'll be able to show you a couple new commands that you can add to your toolkit as a MySQL 5 administrator. So our first step is, how do we take a copy of a table's schema? We have this emp table that has 4 columns nicely defined, and if we want to create an exact duplicate of that table schema, is there a way to do that easily in MySQL? I mean, we could just use create table and redefine all of these columns again, but the good news is that we don't have to go the long way. What we can do is issue create table, and then we'll just call this emp new, and we'll use the like command along with the old table name. So by saying create table emp new like emp, what we've just done is, if we run show tables, is created a new object in our test database, and if we show the create table statement for emp new, we should see that it matches exactly the table schema of our original table. Pretty cool command, isn't it? Now the next question is, let's run a select star from emp. How can we take all of these rows from the emp table and copy them into emp new? Let's review what we've learned. We know that in order to add new rows to a table, we don't use update, but we use insert, right? We use insert into emp new. So far, so good. Next, what do? Well, we can actually use an embedded select statement. Very handy indeed. So we can say select star from emp, and what this is doing in review is we're taking all rows, all column data from emp, and throwing that or copying that into our emp new table. Just as easy as that. So therefore, if we run a select star from emp new, we see that the row count and row data matches exactly what was in the original emp table. What we'll do next is make a modification or an update to some data in the emp table, and then we'll do a multi-table update, which will essentially take all of the specified column data from one table and move it to another. So what we'll do is run update update emp, and we're going to set last name equal to Yeldon, salary equal to 100,000, where ID equals 1. All right, so now we have different data. If we run select star from emp, we see that row 1 now says Tim Yeldon with 100,000. The emp new has Tim Warner 250,000. All right, so how can we update more than one table? Well, let's just say that we want to copy over not last name and salary, but just the last name data from the emp to the emp new table. How can we propagate that update? Well, we can use update, and then we can specify our two tables. Doesn't matter which one we specify first here, emp, emp new. And then we'll say set. Here it's important, since we're dealing with the same column names in multiple tables, that we qualify our column names. Let's set emp new dot last name equal to emp dot last name. And in our where clause, we'll use the join fields, which in this case, the matching column is ID, isn't it? Where emp new dot ID equals emp dot ID. All right, so what this should do is copy the last name data, all of it, from the emp table to emp new. So we're saying update two tables, set the emp new's last name column equals to whatever is in emp last name for all rows, and the where clause just specifies the matching column value, which is going to match for every row in the table. The safe update mode bollocksed us up. Well, I'll tell you what, let's say set SQL safe update equal to 0. And now let's try that multi-table update again. There we go, fine. So sometimes safe updates can get in the way of doing what you want to do. So we'll finish this off with a select star from emp and a select star from emp new. And you can now see that those last names have been updated, or in this case just a last name, across the two tables. Good and good. DML Part 3 of 4 Review. In this nugget, I gave you what I hope is a thorough introduction to the update DML statement. We therefore know what the command is, namely, we use update to modify the content of existing data rows, and I also hope you're familiar with its syntax. I showed you some techniques in MySQL 5 to prevent dangerous updates, and we also looked at table joins and performing multi-table updates in MySQL. I hope that this has been informative for you, and I'd like to thank you for viewing.